Gamers. Yeah, I can't do it as good as... Yeah, but I actually forgot that I actually had that on. I am absolutely fucking... Okay, let me actually also really quickly throw on my fucking filters on so no one actually can see it. Holy shit, it actually worked. Yes! Okay, hello everyone, my name is Biz, and today we are going to be coding some shit. What the fuck is that black box? Oh, that's my webcam. Oh, get that, get that up. Fuck, I can't talk. Shit. Why do I have such a small... Right, yeah. They have problems with my fucking bitrate, maybe? Let's try to set it up again to 4 kilobytes. Sorry, to 6. I literally just forgot how to speak right there. Actually, can that even be viewed? This size? I'm actually fucking a little bit scared that it actually cannot be viewed from here. Okay, go on my profile. Yeah, my phone. Maybe I should really quickly just do that. My channel. Okay, no, I don't want to like turn off my ringtone. Oh fuck. Can that even be read? Written? And that can be read from. What about from here? Fuck. Yeah, I am a little bit sick, so keep that in mind before you blame me of something, I guess. I am a little bit sick, so okay, I think this is good enough. If it's not, then fuck it. It will be good enough, and I need to set my phone to be charging. Shit. Why did I also decide to have it? Whoop. Shit. Plug you into the fun lighting port, and why did I just close my phone? Just like that. Just like this. Here we are now. And one of my friends are playing fucking Ark. Maybe I should like do that really quick before someone's IP gets fucking leaked. But yeah. Today we are going to be doing the most exciting thing in the whole universe of programming. We are going to be stepping through my linker to see if its job is actually doing if it's actually doing the proper thing it's actually is supposed to do. First of all, I want to like really quickly get rid of many of these new lines here, which are supposed to tell the linker when, of course, a new line has come. And actually, also, why do I still have this one open? Maybe I shouldn't do that. Okay, so actually, maybe we should actually just right there. Maybe because I've been working on some stuff. Yes, of late. Must have been sick. Fuck. And that is the file system driver for my BIOS. of course, when there's actually a operating system, you need to write your own drivers for this, because this is going to get outdated fast and slow. This is going to be slow and outdated. So, and also in reality, also because, okay, so maybe I should really quickly explain one thing. Let me just go on to GitHub real quick, onto my very own GitHub. Your beers. Whoa there. You are going too fast. We need to stop you. I then really quick go under my repos and go under. By the way, everything that I'm doing here is. Didn't I make that public? Use passkey. Yes. Thank you. Now I'm in. Didn't I make that public? Oh no, I did not. Okay. Well. So I have changed in the way that all the CPUs are laid out. So under CPUs in the old system, maybe I should really go under here and go there and browse files. If we go under CPUs, CPU, you can see that we have, for example, the BCG-16, the BCG-8, the BCG-1680, the BCG-1684, and so on and so forth, right? Which, for example, the BCG-8 was an 8-bit CPU, and the BCG-16 was a variation of the BCG-8, but with 16 bits, of course. That was the old variation, right? The new stuff is that we have different architectures. Now, so please do ignore these ones, the BCG-8 and all these, all of these that I'm right now flipping out of here. So yeah, all of these here. You have, for example, the BC018, the BC116, the BC124, and the BC2. Oh, sorry, the BC224 and the BC232. Right? So the architecture, for example, for the BC018 is an base data bus of 8 bits and a base address bus of 16 bits. You can then have variations. Then you can have CPUs in this architecture that all follow same principle. But for example, with the BC8, you have the base 8-bit CPU, but with the BC816, you have with a 20-bit address bus. And so it is like for every single one of these. Also, I've changed the instruction layout. Now with this, you have a lot more. You don't have as much control over each CPU, but for example, for this, for the architecture that we are going to be making a BIOS for, because I'm not going into 8-bit systems, we have a base data and address bus of 16 bits, and here we have a few things. So now, for example, I need to explain a few things. I need to actually explain a lot of things. Shit. So, I have a few modes. I looked into Intel. I looked at Intel and I said, if they can make it confusing, then I also can. And so, what the BC018 starts up in is something called virtual mode. What is virtual mode? Well, virtual mode is where you have, oh, sorry, wait 2 seconds. Oh, okay, sorry, I got it wrong. it was with the BC-16 I started this. Virtual mode. Everything from the BC-116 and upwards starts in virtual mode for compatibility reasons. Virtual mode says that the data and the address bus are both 16 bits. You have a interrupt vector table, that is 2 kilobytes, and you only have the base address, the base registers. Now, what are the base registers? Well, it is these ones: the A, B, C, D, some segments, the program counter, which is only 24 bits. Then you have, actually, this one should actually maybe be only 16, but do not, we don't think about that. A 32-bit address register, and all of these things. Now, that is what virtual mode is. Now, for example, with this CPU, the BC-16C0, you can enable extended mode. Just lost the connection. Are we up again? I hope that we're up again. Actually, I should actually have fucking done that. Can I do that now? Stream. Nope. I can't do that. Dang it. But yeah, the extended registers, sorry for that, for the bitrate just crashing. So the extended registers are pretty much just like extended registers of the base address, base registers, sorry, for the A, B, C, and D. Here we have AX, BX, CX, DX, which are all 32 bits. Now, I'll only go into detail with that, with this CPU. The rest you can probably figure out yourself. It all gets better from there. And also, there's even one that I haven't even figured out what needs, what can do. So, that is that right now. Shit. Now comes the exciting part. Because I have rewritten how the instruction set works. So if we, for example, look at the BC-18, and I'll really quickly make some space for it. Actually, why don't I just make it in a new... Move to new window. Fuck. Down. So we can see it in full screen. So I've changed how the instructions work now, or how the instructions are laid out. So the instruction layout is the same over all the CPUs right now. You have you have 12 bits for the instruction code and some unused bits that can be, for example, used for variation control. Then you have 2 bytes, optional bytes, can be optional, which is the 2 different arguments. Now the arguments are pretty much the same as back in the BCG-16. So nothing really changed there, except for that I added some more. But yeah, you can see that I added some new things, and changed how it all works. So now, for example, we have a variation here of the move command where AL is there, which is where we're actually using one of the unused bits. Right here and right here. and then a new form of instruction, a new instruction for the move word. Now for some of them here, for example, I use the last part. 2 seconds. 1, 2, 4. Yeah, I use the last 2 bits here to signal what kind of CPU it is. What kind of size, sorry, it is. So for example, here with the push command, it is here on the byte version, it is 0500, and for the word version, we have 0504, and the same with pop. So yeah, that is how the instruction set now works. And yes, it is the same on this one too. Don't worry, I don't want to fuck up anything. Except for I'm just adding a few more things, some new things here. Added some more sizes here. And yeah, so on and so forth. Added float capabilities, added a move float, and so on and so forth. So that is pretty much how it is right now. Now, we come to the fun part of the stream, where we all need to sit through whilst I am debugging this piece of code. This piece of shit here. Now, you might ask, what is this piece of shit? Great answer. Yeah, great question, sorry. Well, this piece of shit here is a piece of shit that is called a linker. Now, does this have only the linker code? No. We have all the rest of the code, but not the linker code. Okay. Yeah. So we'll have to step through it all. Shit. Okay, can I maybe make a condition? If the current flag is that ends with file system.o, I think it was. File system that, no wait, that's ACL. Yeah, I'm using ACL, not O. Now can I do this? Yes, I know the build. Now the debugging time will take longer. Yeah, just like that. Now we have m underscore there, right down. File system.acl. Right, cushy. Now, this line is a new line. So right now we're here. We are right now here. And we need to get through if that one, and if line is not underscore new line. Thank you. I didn't want to fucking go through all this. Okay, so here we get to the fun part. We get to a label. Now this label is offset. I can see. So I pretty much already know what is going to happen. But anyways, I'm going to go through it. We're going to ask, hey, is it referencing something? If it is, yes. Then we ask, what thing are we referencing? We are referencing a label. So yes, just like that. We have the initialize right there. Name equals initialized. Then we have the hex address 133A. Convert that, and then the file. Then we will look through. Now we'll go through. Find out if it's true or false. Slowly but surely. Yeah, fuck. It's fucking hell will be on. That was actually fucked up. Just like that, we got it. And now we'll then set the address here to be here, because the linker is more accurate. Because when we need to reference, for example, like reference labels, the assembler doesn't know where it is, pretty much. It just sets a marker like this. For example, this is a file label, and then the name. Sometimes with labels, for example, maybe var current address. I don't know, but sometimes when we reference something, we can add a null attribute to it. Now I need to really quickly check on if it is high mask. At M1, yeah, we successfully connected to the Wi-Fi once again. Now I want to really quickly listen to what the fuck is going to get set out of my mouth. And what thing is like going to be set first? Okay. Wait, that's at least something. Great. So, yeah, that's right now there. So where the fuck are we? We're right there, and we have just set that. Great. We'll do one of these. Push underscore del underscore means that this is pretty much just an identifier that says that this is a debugging like thing. I should probably have it to like only write if the debugging flag is on, but anyways. This set bpx 42 means to set a reference of So set bpx to a number, and then we'll check what kind of thing it is, and then we'll do something from there. This was used when I did not have these two arguments. So yeah, I have now later learned that to do that. So yeah. So yeah, throwing those values in, setting them once again. Another instruction. Now, can I really quickly check on what instructions it is? That one was that push BP? Then this one is move BP. 0 1 0 0. Yes, that is move BP. That is 1 0. That means there is a register and a register, and that means this one is 1 8. That is, I think that's SP, sorry, and that's BP. Don't ask me how I know. So we are right now in this function right here, and we are on this instruction right now. We should probably really quickly do that. So now we are on this instruction. Push R, F0, drop that in, 2 0, drop that in, set those. Here we have this. Uh, 5 0. That's a byte, right? Yeah, and then 5 9. What the fuck was that? 5 9, that was BP, yeah. And here we have FFFA. I need my calculator because I can't remember how the fuck to calculate those sorts of things. So we said FFFA, that is -6, that is correct. So yeah, right there, right there, right there, push, 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 call, 9 A B D. That was a short one. So from B to D, there's C and then D. Yes, good. Pop R, F there, check, and then return 0. Yes, good. That's 1 2 3 4. That's correct, yes. And now we're going to jump down to this right here. Now here we also got that. And how much was this one off? Oh, 1 3 5 2. 1 3 9. Fuck. Uh, 0 3 0 0. There. That was this function. This. Now I want to really quickly skip ahead for a little bit until we get to the, let's command read, wow, until we get to buffer here. So if it, now how was this made? It was reference label buffer. So if it concat contains buffer and is not a new line, that was right data. This was seek. This was rehabilitate. Wait IRQ. Format. Then it comes soon. Floppy interrupt handler. That's how you write your labels, kids. Okay, buffer here. So if line is not underscore new line. So yeah, 42. Why 42? 42 here. Yes, great. Okay, so we have, so the beginning here is 1 for F2. Now we'll check at the end. This is the start value. Start is at right there. Now we need to step ahead until we get to this times property. And still check if it actually works. 7, 8, 9, A, B, C. That is 0, B. 40. Which is right here, and that AB is that one, so now we're there, now we're here. 12. There. Which was right here. Now we'll get into the ASCII stuff. So 0. That must then be 4, 0, 0. That's correct. Now we have a 0, 0, 0, 0, 0, 1, 10. A 0, 0, 1, 0. That's what was a maximum number of 2 seconds. Is that even a... Why is that a fucking view short? Okay. Okay, I don't know. So we're right now there. 0, 1. And now we get to this big string. I'll just say prepare for that. So the beginning of the string, start of string is at 0 hex 1508. Yeah. And we should end of string. We should end at 1518. So let's see if we are true in that. 1111. We are. That was the end of string. Great. So how much was this one off? Quite a lot. And now we get to an expression that maybe leaves some confused. So allow me to go through the horrible code that I have done right here. So now we're really quick doing some things here. So times, like in x86 assembly, times will repeat a task for x number of times, right? In my syntax, we have times, an expression, and then a one instruction that one thing that can be done. Only one. Remember that. Only one. So here we are saying that the binary reconnect successfully. Great. Buffer short current address, and then and then an immediate 512. Great. Now this is the shunting for algorithm, I think was called. So yeah. So I think I can just like wait until we actually get to term. That's like a little bit interesting. There. That is the current address right now. And s underscore buffer is 14f2. Doing some real quick calculations in my head, aka using this down here. We used about 29 bytes, which is that the correct amount? That is the correct amount. Okay, great. So now we need to do this. The right side is there and the left side is that one. And that will be 26, which is correct. And now we'll do another one of these, where the right side is that one and the left side is that one, which will give us 1 DA. Now our objective right here is to go up there. So if we say 26 minus 1 DA, I meant to say plus. Okay. Now let's see if that is also the reality. The result is right there. And it is 0, 1, DA. Correct. Now times is, of course, that. Oh, wait, two things. It is 1 dB. One dB. Oh, we are artificially adding 1. Why are we adding 1? Oh, that's why. So now, our start here is right there. And so our end should be one there, F2. Right here. Okay, all ready? Just 1 over. Literally just 1 over. Why are we artificially adding 1? But yeah, that means that it does work. I just didn't trust in it. And the reasoning I didn't trust in it is actually quite simple. I looked at the wrong addresses. Right, these ones don't tell anything. But always, as it is, as the linker yay, we connected. Okay, so what I should have done was that I should have... We only have test label. Why do we only have test label? We should not just have test label. Is that because that the rest of the labels are... They're local. Right down. Which we can see that checks out. That is 1 6 right now. And I absolutely love, right? So, fun fact, right? So, the whole BIOS, right? The whole BIOS right now fits within to right about here, right? That's the whole BIOS, nothing included. That's just the whole BIOS right now. So, like, that is so fucking amazing. And even, I think actually I can do it a little bit better even. So, the things that's getting... So, BIOS functions, why is that getting offset? So it isn't. It's just getting offset that much. Oh no, wait, things. Okay, so yeah, fuck. So if we look into here and then say full end label, that means that this is the full end. Nothing comes after this. And we'll actually place it right here. Right? So the full end is right there, right here. Now we have an offset that says right there. And then we'll say 1779. Fuck, I just did that wrong. Minus, what did I just say? It's 1200. I have just reached 1 kilobyte. Oh, sorry, 2 kilobytes in size. The BIOS code fits within 2 kilobytes right now. Granted, this is not tested yet, but the main functionality of the BIOS, which is to set up a small descriptor table sets up some of the vectors in the vector table, sets up a temporary stack segment, finds the boot drive, and then jumps to over here, that then reads that sector where the boot drive is and jumps to it. All of that code reading a sector is and also reading to a reading and writing to a sector, rehabilitating the drive, unfinished some of the BIOS functions, some IO functions, all fits within 2 fucking kilobytes. Actually, how much is it actually in practice? Like, how much is it actually? It is... Now, what should I actually like do there? No, it's not kilobits. That much I already know. Says here. Not even 2. 1.3 kilobytes. Try to beat that. And I don't even know how. Like, I think that is actually because I like have optimized my fucking arguments that much. Though there's maybe some question in how efficient maybe my CPU is per clock, for instruction per clock. But yeah, that is actually fucking cool. Now formatting a floppy disk normally just like does actually how does formatting a floppy disk work? How does formatting a floppy disk work? How do I format a floppy disk in Windows? No, I don't want to. Yeah, floppy disk formats. And density, sectoring. The formatted disk capacity is always less than the raw unformatted capacity specified by the disk manufacturer. Yeah, okay. So so formatting is just wait, 2 things. So formatting floppy disks. Maybe I should actually really quickly ask how. I don't want to know how. I want to know what happens. Fuck it. Fuck it, actually. Literally just fuck it. Okay. So yeah, I think actually that works now, I guess. So okay, yeah, I don't want to like do all that. That's for the operating system to do. I don't want to do that. So I think we are clear to return with a 1 right there. Right after leaving the current thing here, enter. Yeah, I've made these fucking like enter and leave instructions that pretty much does does this literally. Push BP and all that. Does the whole like process for you, so extra clock cycles for me, I guess. So I should probably like what the fuck? So how many bytes it is? 1, 2, 3, 4, 5, 6. 2 seconds. 1, 2, 3, 4, 5, 6. And now this is 6, there's 10, 7, 8, 9, 10. 10 in total. So return with 10. That's the offset. And this one is 1, 2, 3, 4, 5, 6. That also is there. Now this one, we could actually do return 0. But we actually have a parameter. Sorry. Fuck. And we should probably also make the make day enter and leave. Enter, yes, and leave. Enter, leave right there. Enter, enter, leave, enter, leave. Enter, enter, leave, enter, leave, leave, and enter, enter, leave, yeah. But like, I think, like, I still don't know how the fuck I've gotten it down to under 2 kilobytes. Can it just be because my like assembly code is so fucking like optimized? That can't be a fucking reason. On a different topic, I don't actually have a fucking topic out. Like, I'm like normally when I fucking stream, I don't really like think. That sounded fucked. Normally when I stream, I don't think. Okay. Not new line. Enter. Like at some. Oh yeah, we could also. I could also do that. Yes. Thank you. Thank you for that, fucked up brain. So, did we have any more? Yeah, of course we have that one, but I don't really think that one's not a real function. Already done. Already done. Great. Grape. How different? Okay, just fuck it. Okay. Me just got confused. So yeah, and we don't say 2000 anymore, which is what was 2000? Flags, which is nothing. Right? But I know that this is clear interrupt. I know that as a matter of fact. I know that that is a clear interrupt. And this is a set interrupt. Can you see I'm beginning to get more mainstreamed? Let me see. So yeah, actually, how big is the sectors? Is the what they actually call them? I called them like what they actually call my things right here. They call them sections. I call them sections. Yeah. What? How big is my sections? That one is fucking big. Also kind of big. Kind of small. 0. Literally just like 0. Yay. Wait, this don't, wait, what the fuck was I just about to say? This don't make sense. Huh? Okay. Holy shit. This don't make sense. Okay. Well, now that we got that one theoretically working, what now? I've been pondering for more than a century. Like, we could do that, but I think that's just like a little bit too boring. Going ahead and debugging like commands and all that. So what could we add? What could we actually add? I don't actually know. Frankly, I don't actually know. We could work on a fucking emulator. Great fucking idea, Bjorn. But to make the emulator work, we need to get the file system to work. Okay. What I have right now in the file system is this. If you don't know what this is, well, this is the this is one sector in size, and this is the time in microseconds, I think it is, the time in which all of this, and also printing to the console, how much time that takes. This is if it did sleep, so if we had enough time to actually sleep. And this is a sample overall. This is a sample if we actually on how much time on average it took for each of them. So, but this can be optimized, like many other things, like myself. So if we really quickly do all this and not send any data, we get this. It takes on average 0.1 milliseconds, is it? It's actually milliseconds, sorry. To read. And I've set it to be at 200 milliseconds. So what this code does is that it checks, it sets the track 0 if we are on track 0. Then we check if it is write protected, which we should probably do down here, but actually no, we should actually do it up here, yes. Then we will do the hit thing, and then we'll check if the motors are enabled. Now here I need some more code to also figure out all that. So then after we check if the motors are all that, then we'll disable it and retry all the sectors again. This needs to be deleted, don't worry. We have a, like, on average we have, oh actually, yeah, this is the thing, yeah, great, fuck. So yeah, let's actually do 11F instead. Why 11, you might ask? Well, 11 milliseconds is the amount of time that takes it to actually 11 milliseconds, right? Is the time that the read, yeah, okay, so fuck, how can I actually explain it? Okay, so each sector on a disk, for the head to move over, actually, how can I actually do it? See it. Okay, so it takes 11 milliseconds for a sector to move over and move away, or move to the end of the sector. That takes 11 milliseconds. For the whole disk, because we are running at, what was that, 500 revolutions per minute, per second, sorry, 500 revolutions per second, or was it per minute? Yeah, it was per minute, sorry. That means that we have a revolution every 200 milliseconds. Divide that by the number of sectors that we have, which is 18, and you have what is it, maybe, yeah, then you have 11 milliseconds. So one revolution all around for the disk and for the motor takes 200 milliseconds. And for each sector it takes 11 milliseconds. That's how. Then we call a function here that is pretty much just like, hey bro, read this sector. Great. Then we have the sector data, the sector data that we then loop over and put it in the read data. Normally on a floppy disk like this, it takes it only gives away 1 bit at a time. It only gives us 1 bit at a time. Right? Using a fucked up system, I just decided to plop the whole thing in there and just let it run, I guess, because it probably takes enough time. Then okay, I don't want to like just how fast is actually my Wi-Fi? And no, I don't want to dox myself, so no thanks. Yes, you can know my location. Okay. Okay, that is 14 ping on average. Also on average, we have nearly 50 down and 52 up. Okay. Cool, I guess. If I'm gonna use that information to do anything, no. I need to have my yeah, great. So that is how the floppy disk. That's how it works when reading. And this is all captured within a update state that just does all that in a thread. So the thing is, how many threads do I have running? That's actually a good idea, a good question. Because, yeah, how many threads do I actually have running at once? I of course have one here on the BCG-16 bus. I also, on average, also have one here. For the most part, even though it is actually... You shouldn't actually do that as a thread, but hey, I've done it. I should probably actually do... this. Oh wait, so since I... Oh, for fuck's sake, right there, great. Just do that, just because. Okay, so... We also have one here, running all the time. Do we have any other asyncs? I don't think we have. What about on the chip itself? Do we have any async there? No, we don't. What about the ports? Yeah, what about actually the ports? Because how many... We don't actually have any asyncs there. Great. And also none there. Fuck. Shit. So one it is, I think. I actually think, yeah. 2 threads, maybe 3 because the main thread. So I have 3 threads. Okay. How many cores and all that do I actually have here on my laptop? I'm all fucking ready. I have 4 cores with 8 threads each. What? How the fuck did I just say that? So I don't think 6 threads should do anything fucked. Python can do like 400 threads, so I think this works, I guess. I guess this works. Warning label, you need fucking so many. Like, it ends up there. I need to actually like make a warning and say, you need a fuck ton of threads to make this work. Yeah. Actually, I think actually I've already said this before, but the reasoning that beforehand I have only had a few memory banks at a time. I think it's in here. I have a really quick browse. Let me see. Can I actually find that real quick? Give me a minute. In here maybe. If I go on here. Oh shit, this looks terrible. So have I ever told you the reasoning why I started out with only 4 bits of memory? I don't think actually I have, but here's the reasoning at least. if I have it, if I already have taught the reasoning, I'm sorry, you will get it again. That's because of this. I had to have, let's do a little bit of calculating here. Right here, +1, right there. I had to do 16 megabytes. And to reassure that this is 16 megabytes, I will really quickly throw it into the calculator. Right there, 16 megabytes. Right? I had to spread that over. Okay, so which isn't actually that much, right? It isn't actually that much. Like 100 two. What was it actually? It was 256. Yes, 256 megabytes. Megabytes isn't actually that much, right? If I had to do 256 banks all at once, I had to ask the end user to have 4 gigabytes of RAM. This laptop that I'm on right now has 16. Right? And also this isn't even the worst part, because I was thinking about doing a 32 bits. Spread that over 256 banks. You get 1 fucking terabyte of RAM. and I couldn't ask the end user to have 1 terabyte of RAM. And not at all 1 terabyte of disk space. I don't even think you can have 1 terabyte. What happens if I actually try to allocate 1 megabyte of RAM? Go to new bytes right there. Now, the program right now is running on my C drive, which doesn't have that much space here left. So actually, let me do the tests on the actual file that I've selected, and the actual process that I've actually selected. Let's see. 1 terabyte of data in bytes yields us an system overflow exception. Array dimensions exceed supported range. No shit, Sherlock. Now you might ask, hey, what about just half a terabyte, right? It can't be that bad, right? It can't be that bad. It's still half a terabyte. That's still crazy to ask an end user to have. And half a terabyte still is too much. And then you have those nerdy people out there and to just insist, well, you could of course also just go down to quarter. All the way down to a there or there, I guess. Now, how much is this? I think this is 64 gigabytes. This is 64 gigabytes. Right. Now, first of all, tell me, do you have 64 gigabytes in your storage right now? Because if so, I will allocate all of it. And actually, no. I actually think the supported thing here is all the way down to 16. I think I have not tested this yet. Is it 16? No. So then it must be 8. Let me actually test that. I actually want to test it. Right? So nope. Okay. So 4. I should probably do this in hex. So here maybe? This is 1 gigabyte. Okay, nope. You can't just casually allocate 1 gigabyte. How sad. Now what about... No. Okay. We'll go down to hex 4. Okay. Okay. And what about anything over that? You can still do that. Is this the limit? That is the limit. Actually, no, wait, 2 things. I haven't actually tested all of the other different things, so I'll just put a +1 right there. That means there's 5. Wait, nope. Okay. So 7 FF all the way up gives us a no good. Great. What about a 6? A 6 is good enough. What about 7? It's also good enough. So it's somewhere within 7 here. What about 7, 8? 1, 2, 3, 4. Okay. What about 8? Oh, that's why. So D word. Yeah, that's not like... So what is the... What is the max size of an array in C#? What is the maximum size of an array? That's a uint. And if I now run this, we should not get that. Great. And if I then say +1, or 100%, I am right now killing my computer. We're still doing it. The bastard's still doing it. +2. He's still doing it. Okay, so +1 means this one rolls over, roll, roll, roll. That means there is 0, 1, 2, 3, 4. F right here. Now, if we really quickly do... Alright, so this is an extra 64 kilobytes. +1. Great enough. And here. Right there, yes, okay. What about half kilobyte? Oh, is it actually maybe just a fucked up arbitrary number like if E maybe? Okay, dang it. It could have been so fucking cool. So what about actually 9? 9. Wait, 2 seconds. What about E? Right here. Right there. So I think, yes, this will give us that. So yeah, now we have the complete size of it. And if I plug this into a calculator, and I can already see the data right there, that is 2 fucking gigabytes. And even though I maybe like, it's such a fucking weird number. Like, what? Yeah, the 12th bit is off. It's such a fucking weird number. Now, what if we actually like shift this one down, like 4? Okay. FE, FF, FFE, yes, okay. What about... No, I don't think that bit does anything. Okay. A. Okay. We'll take a big jump here. And say D. Okay, nope. C. Maybe. Okay. B. Counting the alphabet with Biz. What a nice time. Now we can begin to test that one out. Now I will set it down to 8. It did not pass. What about 0? Now we have a range between... Okay, now we have a range between there and there. Now we can begin to count up. Let's take a big jump. Let's take 4 here. Holy shit, he takes 4. Now, what if it's just 77? Holy shit, I found the actual limit. And still it's a weird number. I think this is the absolute limit on how big an array can be. And Google told me the same exact fucking answer. The maximum integer index in any single dimension is Yay, great. So, okay. Well, I need to really quickly run. So, because I need to get some food, I'm just going to throw up my be right back sign and call it a day, I guess. I will be back. I will be back. So, wait around, because I will be back. Ladies and gentlemen, welcome back. Fuck, man. I literally ran up the fucking stairs, so... Sorry if I'm a little bit, what's it called? What is it actually called? In fucking English? Exhausted? Is it called exhausted? No, it isn't called fucking exhausted. Is it? I can't actually remember what it's called. What it's called in the fucking... in English. But hey, we've now hit fucking 2 hours and 4 minutes of streaming time. And only half of it has been like me going down to eat. But yeah, we found the maximum thing there. I don't know what the information will be good for, but okay. Okay, so we need to test the drive. So formatting right there, which I guess is good enough. We have right there. Now, what we actually just need is for the bus / controller, which is the BCG-12, to... It is for this one now. The thing is, now we have a little bit of a predicament, a little bit of a question here, because when we finally, yes, we are finally reading the disk. When we're finally reading the disk, actually, okay, I think, yeah, I want to rewrite a lot of this code, so, yeah. What was the specification for the floppy disk drive again? Hold on, the architecture's there. So yeah, nothing really serious have changed about this one. Yep. Dang it. I was just about to fucking like speed test it, but didn't do it. Dang it. Sadly. Okay, but yeah, we need to, first of all, we get we write in the disk, the drive, and the head. Then we write in the track, the sector, and then send the size in multiple of 128 bytes. And then return read from the data register. Now, will that have to maybe be like 2 words at a time? I don't think so. Okay, so disconnected. Allow. Oh. Okay, it's literally just disconnected. My Wi-Fi just disconnects. Wow. That's actually fucked. But then we'll do all of this here. Now, depending on what the command gesture is, we'll have to do something. Now we have all this. I think we can just like make this an else thing here. And here, if we actually do that, then we'll just return out there. Okay, I need to fucking draw up my like my shirt here. Great. So using this information, using the drive here. Now, how big is the argument? It is right there. Great, Gucci. Now, what kind of data are we sending in? Oh, now we also need to actually have a drive number. Ooh. Now this must be slot. This slot right now. And we very quickly do all this. And do that. Great. Then we don't need to format it, because we just don't need to do it. But what do we need to do? Actually, not a whole lot. Okay, so all of this we can delete. Yeah, we don't actually need that much. Because the rest is up to the programmer to do. That also means this one and this one that we can actually just make non-public. Right, just like this. So these two things we don't need to do because, yeah, we don't need, I guess. But we probably should save it to the file. Save the file at least. So now we say it is in use, and then we'll do this. So this is pretty much just like a failsafe if something fucked happens. Okay, so let's really quickly test if this one works, because two things, do we even fucking set it? We don't even set it. Maybe we should also set it real quick. M_. master status, which is a ref. There, and then we need to say that it is true, and the thing that we need to say that is true is that one and true. So if we look into here, then we can say user bright. So if this one is on, then the user just can write stuff. And we can make a thing here to not to do a dry. Don't repeat yourself. And do all that. I think we are ready to go. I should change that. I hope we are ready. Oh fuck. Really? Oh. Yeah. No, okay. I think I see that. I do believe I see that. I really do believe that I see that. And that's not good. So that is on like that's on like anyone else to do, but not the floppy disk controller. The floppy disk controller should not should not do that. The only thing that we do is that we set up some parameters internally for the file system. I was just about to fucking speak speaking German, but I luckily didn't. So yeah, now we can go into here. When we create a new disk, we also now need to format set disk. Just like this. Now this is true, so we will take in the first argument, which is apparently a 0, which is not true. Fuck. I know that was not a sneeze. That was literally just a cough. Then we'll set that one. Then we'll go in there again. Command register right there, and we don't have that. So we'll go into here. And oh yeah, 0, yeah, fuck sake. I'm trying to swear less. Can't I just like do this real quick? So this one 0 0 0 0 1 2 we do have head 0 and drive 0. Okay, so now we need to make the conscious decision. Do we go the apple direction where each like for example reading from the disk, you need to be at a certain point. Do we do that, or do we let it seek itself? I think I'm gonna make the most adult decision in my whole entire fucking life and let it do its thing. Now the get drive. That's not the correct. Now I don't actually need to do this anymore. So yeah, sometimes we also have another thread here. Okay. Now oh. Okay, so it's not just okay. Okay, I just figured out something. Okay. I sound like a fucking shocker. Okay. 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 Okay, so we need to first of all check, are we at track 0? If we are at track 0, then it can only go one way. Direction equals to, and how did I make that? I made it so that if it's false, then we will go forward, and negative false, and false up, true down. So then we only have one way to like go. So step 4, pre-track amount of times. Then we will just do this. And then here we can probably also do an await task run. Right here. Okay. Right now. Now, if it is not on track 0, then we actually have a bit of a big problem, because we do not know where it is. But should I have a register on board saying I should probably? And I will also do that. Track register. So if we're on track 0, then we will just step forward all the time. Now okay, so now how do we do this? It is somewhere we only know where it is using this track right now. And we have the pre track, which is the track we need to get to. Actually, outright, can we just ask, first of all, is this one the same as this one? Because if it is, then we can just say, then we can literally just say, fuck off, boys. But now we'll have to say if the track register is lower than this one, then we'll need to, so if this one is lower then we need to go up, else we'll need to go down. But for how many times do we need to do it? So we could 2 seconds. We could enclose all this in a loop that goes like 80 times. We could then break out of that loop once we finally get there. Now we need to say if the track is under this one, then we need to go up. So up, that was drive dot direction equals to false, and this one was true. And each of them says drive dot step. And then we really quickly need to set that one to true, because we set it to false here. Okay, so that was that. Now we can kinda seek to a track using a drive. Now we should probably also have a buffer on board. Actually, do we have a buffer? We don't. Yeah, but talking about this one. And this can just go away.
Okay, so we have the head and we have the sector. So now we can do a head select. Now if the head is 0, then we need to set it to true, I think. Head select equals to true. Else, if it's anything else, then we need to set it to false. There's the head. The track we already have using the current using the current track in the drive, and the sector. Now this is the hardest one because now what we need to do is that we need to wait until what the fuck is this? Okay, I think what I'm gonna do is I'm gonna make it a little bit, change it a little bit. So I think I'm gonna first of all ask, whilst that the index is false. Now we have precisely 11 milliseconds to do something. To check if it's the correct hole. Now, if the sector is 0, actually, okay, so, and then we'll do right there. Okay, so drive equals to get drive. No, that is literally the most times I've said drive. Fuck. Sorry, people. I just fucking coughed into the mouth. Into the mouth. What? Into the. Yeah. So now, whilst this one is false, then we'll have an external thing called current sector, because we can only record that whilst up to a grand total of 18, I think it was. Actually, we already have a thing here that's literally called current sector. So the current sector starts out at 1. goes up to 19. Now, if the current sector is the same as the sector, then we will break and call the read data function. Actually, isn't that the only thing that we need now? Because all of this is no longer in use. Yeah, it is. Okay, so an int. Very short read. So now we can do an await task dot run into there. Now comes the funny part. Hey. Because now we need to actually like read. And we need to read at a constant pace. Two seconds. If we really quickly make the load stop. That's it. Byte hit right there. So read sector, the only thing that we need is the hit. Now, if the motor is not enabled, we will still want to just read the data. But when do we know that it has to that it starts? That's actually kind of a interesting question right there. Pinout guides. Which one was it? It was this one. Very quick go into this. Oh fuck! It is fucking bright. This one. Now, when we need to read the disk, and in later floppy drives don't need this info as they automatically read it from. Okay, nope. Floppy reading from a floppy disk drive. Reading from a floppy disk. How to read on a floppy disk on a modern PC or Mac. Yeah, I'm not talking about that. I'm just talking about actually let's try this one. Okay, it says a fucking floppy to USB. Floppy to USB. Uh-huh. Oh, here there's actually something. Actually, maybe OS dev maybe has something out. Maybe. Um. Read slash write. Thank you. Send the command or read command slash write. First parameter. Second parameter. Third parameter. 4th, 5th, 6th, 7th, 8th. First, second, third, fourth. And then let me see. So yeah, how do we actually? How does the read work? Floppy media or electronics. Okay, but like when the motor is like fast, what the fuck do I then do? Okay, there's a fuck ton lot of here. Wait, there was that one. What about this one? This is right here. Now, what if we really quickly search? Let me see. Read sector, read da. Okay. Um. Drive B, drive A. Oh. 2 seconds. Oh, fuck. Okay, so. Oh. Okay, so what I've just gathered up is that oh yeah, I'm just figuring shit out. Shit. But how does it read data? DMA, some other things. Yeah, commands. Oh, this is just mid-sector right here. Okay. But fuck that then. Go back to here, I guess. Actually, sorry, here. For fuck's sake. Actually, what was this? Disk change. Disk change. What's all that for? What's all the hype for there? Nothing. Okay, great. Fuck. Okay. Alright, we can also disable those two. Actually, we need to enable the load here, and then we need to enable one of the selected drives. And it doesn't mean that it doesn't equal to be track. Actually, over here, we now say if we have m underscore, or actually the motor a enable, or if we have motor b enabled, and the same over here. I think this is the correct thing, because then that means that we can have 4 different floppies in it. But like 2 seconds. Wait, no, wait, we'll just go back to the old system. And then we'll have to do all the motor shit later. How long has it actually been now? About 3 hours, okay. But the rest we'll do later, I guess. So then we'll turn load off. Fuck. And now we need to figure out when it's actually done over here. Right now we don't have anything right here. And these are the only like outputs that we have, at least according to that. But I have found a beautiful thing here on the actual connector here that goes into detail what the fuck is happening. So of course I have an interrupt, a cable select, aka chip select, an IO read and an IO write. DDRQ. What the hell is DDRQ? I don't know. But this is the actual interface to that. Which 2 things, does that mean that this is kinda false? Or what? Or what? 2 seconds. So the ground. Many of all of these doesn't look like it's ground. Actually, if it's like ground, 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 then it maybe makes sense. But why not utilize all of them? Just asking. Key or VCC in. Data direction request, no. DDRQ. What? does DRQ stand for? Okay, that didn't give me that much. IO char ready. Okay. Oh yeah, all these ones, all the what's it called? I cannot. Fuck, man, my English is fucked. Most of these odd ones are like just not there. IRQ there, control signals, all that. Yeah. That's in the DMAC. Why did DMAC? Okay. But holy shit. Is this just in for? Yeah, this is just for the Intel one. Holy shit. That's actually a lot of information. Just right there. This drives. Okay. Oh fuck. Is this just all in the forums? I think. Yeah, these are all just in the forums. Yes, okay. So. Oh, maybe actually we could check out. Here we have something maybe. This directly interfaces. I've just found a thing. Sorry. I've just found a thing here that says open DOS, and I actually really quickly need to pull up my microphone. Hello? Okay, great. Because else it didn't fucking work. Argument, drive, head, track, sector, count. Okay. A whole bunch of things here. Okay. I'll have to look into that because, yeah, shit. Now, kind of, okay. Hello, now it's time for me to read through this once more. I have already read through this fully once, so this should not be that big of a deal. Right here. A set of 9 bits is required to place the into the read data mode. After the read data command has been issued, the loads the head if it is in the unloaded state, waits the specified head settings time defined in the specify command, and begins reading ID addresses, marks, and begins reading Okay. So the only thing I got out of this is just get good. Actually, let's actually just make a while loop whilst that the current sector is not that. Let's leap for 10. I guess we have probably already used one of them already here. And if not, then we're gonna do it there. Okay, so whilst it's not the same, but if it is the same, then we'll do that. Then we should probably sleep for 11. Because this one just goes around 11 times all the time. Okay, so then do that. Plus also there will be some overhead and all that shit. Fun shit. Okay, and then we will throw off load. As soon as we got it. Now, what we now need to do is that we need to wait. I think actually I want to do -1. But if we pass over the index hole, then we are in a little bit of trouble. Yes, I always do that with not implemented exception. Okay, actually, there's one thing that we could do, and that's to pretty much state in a special array of bytes 55179177 x 55. Say in a specified number of bytes that, hey, we are actually reading something. Or we could, of course, also just simply break out of it a little bit and no one said I could use a clock. That's my excuse, okay? What is your excuse? Now the only thing that I'm a little bit scared about is that it is going so fast that this shit over here isn't going to react fast enough. That is the only concern that I really have. But apart from that, this should work. Okay, so and no matter what, we always set it back to 0. So right there. Okay. So actually, I don't think we need to do that. Actually, we should probably also do a sleep 11 here too. Yeah. Set flag, master status gesture. Okay, so okay. Now we need to do a what should we actually do? Now we should first of all say that that load is true. Then we should go into for loop for size +1. Actually, not +1. Okay. Okay, so first of all, we are waiting for a clock signal. When we got the clock signal, we should then do derive dot read data and do that over and 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 over again. And actually, we should probably do this in a while loop, while that the bytes that count is not the same as the size. Doing all this, waiting for that one, writing it in, jumping over there. Now should probably also have a while loop saying if clock is false. Like just sits there and does something. Oh really? That fucking knees deep? Okay, so sector one there and then 2 is there. The size is 2, which is also good enough. Now we'll really quickly do all that. Are we at track 0? Yes, we are. then we'll go up for no time. Then also place another breakpoint? Apparently not. Alright, let's really quickly redo that for a moment. Right there. Let's select one. So whilst index is 0, uh, false and false. Oh fuck. Drive select A is also true, no matter fucking what. Okay, so right there, right there. Fuck that one. Sleep until isn't this one? No, it's how do we add the drives? We add it by 1, 2, 3, 4. That is fucking why. Wait, right there. Okay, so right there. We literally just had it. Whilst current sector and sector is not the same. Around 2 seconds. Drive stop. Okay. Okay, that's 6. I don't know why it's like running twice. Okay, I think I'll have to stop it here. Like the stream. But anyways, like 3 hours and 8 minutes. That's the longest stream I've ever had, I think. So yeah, I think I'm gonna end it here. Thank you all so much for watching this stream, and check back next time whenever I go live. Probably tomorrow, hopefully tomorrow. Yeah, so yeah, goodbye.